You think you understand reality? Electrons orbit atoms. Matter has mass. Energy is positive. Simple physics. Stable universe. Then, in late 1927, a 25-year-old physicist staring into a fireplace at Cambridge starts taking the square root of an equation that should not have a square root. What he finds does not just break the rules. It demands that for every particle in existence, there must be a perfect mirror particle with opposite charge. Antimatter, a parallel shadow universe hiding in the mathematics. But here is what nobody tells you. Dirac did not believe his own discovery for 3 years. He fought it. Twisted the equations, tried to make the mirror particles into protons, failed. And when he finally admitted the truth in May 1931, he called it pure cowardice that he had not seen it earlier. This is not a story about a genius having a brilliant idea. This is a story about reality forcing itself through mathematics, one agonizing step at a time. If you value documented physics and mathematical history like this, subscribe. It is the best way to support our work. Also comment from which city you are hearing this from. This script is researched and factual, using sources from the Proceedings of the Royal Society A, where Dirac published his 1928 equation, submitted January 2nd, from the American Physical Society's archives, tracking the equation's development through late 1927 I, from Carl Anderson's 1932 cloud chamber photographs at Caltech Archives, and from Hermann Weyl's 1931 symmetry proof published in Gruppentheorie und Quantenmechanik, second edition, showing the mass equality requirement. Now back to the information. Bristol, England, August 8th, 1902. Charles Dirac, a Swiss-French teacher, sits across from his son Paul at dinner. Father speaks only French, mother speaks only English. The boy learns early. Words are dangerous. Silence is safer. At Merchant Venturers Technical College, where his father teaches, Paul excels in mathematics but barely speaks. Graduates at age 19 from Bristol University in 1921 with first-class honors in electrical engineering. Cannot find work. Post-war Britain, economy collapsed. No jobs for engineers. He takes a free mathematics course at Bristol. 2 more years. First-class honors again in 1923. Applies to Cambridge. Gets a £70 scholarship. Not enough to live on. The college makes an extraordinary decision. Increase the scholarship. They are betting on a silent boy who speaks in equations. Cambridge, September 1925. Ralph Fowler hands Dirac a proof copy of Werner Heisenberg's paper on matrix mechanics. Dirac is on vacation in Bristol. He reads it, sees a strange mathematical relationship Heisenberg cannot explain, returns to Cambridge. Suddenly realizes the structure is identical to Poisson brackets from classical mechanics. This is the bridge between old physics and new. Dirac is 23 years old, has not finished his doctorate, but he now understands quantum mechanics better than almost anyone alive. June 1926, Dirac submits his PhD thesis. First thesis on quantum mechanics submitted anywhere in the world. He is 23, already lecturing Cambridge professors, competing alone against teams at Göttingen and Copenhagen. Erwin Schrödinger publishes his wave equation. Werner Heisenberg hates it, calls it aesthetically disgusting. Schrödinger despises Heisenberg's matrices. The field is at war. Dirac sees they are the same theory in different languages, creates transformation theory, unifies everything. He is becoming dangerous. Late 1927. The problem everyone cannot solve, Schrödinger's equation works beautifully for slow electrons, fails completely for fast ones. Relativity ruins everything. The relativistic energy equation has a square root. Energy equals the square root of momentum squared, plus mass squared times speed of light squared. Schrödinger tried this, got an equation with second-time derivatives. Wrong. Gives negative probabilities. Physical nonsense. Klein and Gordon published it anyway. Everyone knows it is broken. Dirac has an idea. What if you do not accept the square root? What if you force it to factor? Dirac sits at his desk in Cambridge. Engineering training kicking in. You cannot work with square roots in differential equations. They expand into infinite series, impossible to solve. But what if the square root is not really a square root? What if it factors into something linear? He writes, energy equals some coefficient times momentum in x direction, plus another coefficient times momentum in y direction, plus another coefficient times momentum in z direction, plus a final coefficient times mass. Square both sides. Compare to Einstein's formula. The cross terms must vanish. That only works if the coefficients anti-commute. Coefficient 1 times coefficient 2 plus coefficient 2 times coefficient 1 equals 0. Numbers do not do that. 2 times 3 plus 3 times 2 equals 12, not 0. Dirac knows this, but matrices can anti-commute. He's been swimming in matrix mechanics for 2 years. He tries 2x2 matrices, the Pauli spin matrices from spin theory. They anti-commute beautifully, but you need 4 coefficients, not 3. Pauli only has 3 matrices. Dead end. December 1927, Dirac makes the leap. Why stay with 2x2 matrices? Go to 4x4. The mathematical cost. Your wave function now has 4 components instead of 1. The physical meaning, unclear, but the equation works. He writes it out, tests it on the hydrogen atom. The fine structure comes out perfect. Schrödinger's equation could not do this, but something else appears. Something Dirac did not ask for, did not expect, does not initially understand. Electrons spin, the magnetic moment. It emerges naturally from the equation. Half-integer spin, exactly what experiments measure. Dirac has not added spin to the theory. Spin is in relativity itself, hiding in space-time geometry. The equation is telling him something profound. January 2nd, 1928. Dirac submits the quantum theory of the electron to Proceedings of the Royal Society, A. 25 years old, working alone, the paper hits like a bomb. Heisenberg is shocked. Born is energized. Pauli is suspicious. The equation is beautiful. But there is a problem everyone sees immediately. The equation has 2 solutions for every energy, one positive, one negative. For an electron at rest, you get positive rest energy, normal, expected, but you also get negative rest energy, minus 511 kilo electron volts. What is a particle with negative energy? Classical physics says impossible, but in quantum mechanics, you cannot ignore solutions. The negative energy states exist mathematically. Therefore, they must exist physically, or the equation is wrong. Dirac wrestles with this for 2 years. At first, he hopes the negative energy states are just mathematical artifacts. But the equation is too good, explains too much, predicts electron spin exactly. The fine structure is perfect. The magnetic moment comes out right to 1 part in 1,000. Later, quantum electrodynamics will refine this to 1 part in 1 billion. The equation is not wrong. So what are the negative energy states? Here is the nightmare. If negative energy states exist, every electron in the universe should fall into them. An electron could emit a photon, lose energy, drop from positive energy to negative energy, then emit another photon, drop lower. Again, infinite cascade. All matter would collapse into an infinite sea of negative energy. Radiate away, disappear, the universe should not exist, but it does. Dirac needs a mechanism that forbids electrons from falling. Early 1930. Dirac has an idea so audacious it borders on insane. The Pauli exclusion principle. No 2 electrons can occupy the same quantum state. What if all the negative energy states are already full? An infinite sea of negative energy electrons filling all of space, from minus infinity up to minus the electron rest mass, completely uniform, unobservable, like the 0 level of electric potential. We only see differences. If the sea is uniform, we see nothing. This is the vacuum, not empty space. A sea, packed full. 1 electron in every negative energy state. The Pauli exclusion principle now forbids normal electrons from falling. All the negative slots are taken. But wait, what if 1 negative energy electron absorbs energy, jumps up to positive energy, becomes a normal electron? That leaves a hole, an empty state in the negative energy sea. How does a hole behave? It has positive energy, because you had to add energy to create it. It responds to electric fields. If the electron that left had negative charge, the absence of that negative charge looks like positive charge. A hole behaves like a positively charged particle. With the same mass as an electron, Dirac has mathematically predicted something that should not exist. But Dirac does not accept this, cannot accept this. There's only one known positively charged particle in 1930, the proton. So Dirac makes the identification. The holes must be protons. Electrons and protons are the same thing. Protons are holes in the negative electron sea. This would be beautiful. All matter reduced to one fundamental entity, the electron. The dream of philosophers. Unification. One particle explains everything. March 1930. Dirac publishes A Theory of Electrons and Protons in Proceedings of the Royal Society. A volume 126 announces his hole theory, identifies holes with protons. Almost immediately, other physicists see the problem. Heisenberg writes in December 1929, the hole must have the same mass as the electron. The symmetry of the equation demands it. Hermann Weyl confirms this. Robert Oppenheimer calculates the annihilation cross-section. If Dirac is right, Electrons and protons should annihilate constantly. Matter would disappear in microseconds. The universe would be pure radiation. But here we are. Solid matter. Stable atoms. Dirac's theory predicts our non-existence. 1930. Igor Tamm meets Wolfgang Pauli at a conference in Odessa. Pauli has proved rigorously that, on Dirac's theory, the interaction of electrons cannot destroy the equality of masses of electron and proton. Tamm reports back to Dirac. Hermann Weyl publishes the second edition of Gruppentheorie und Quantenmechanik, shows using symmetry arguments that the whole must have the same mass as an ordinary electron, not 1,800 times heavier. The proton identification is dead. Dirac knows it by late 1930. But what is the alternative? May 1931, Dirac writes a paper on magnetic monopoles. Almost as an afterthought, he includes a paragraph on the whole problem. He admits defeat. It thus appears that we must abandon the identification of the holes with protons and must find some other interpretation for them. Following Oppenheimer, we can assume that in the world as we know it, all, and not merely nearly all, of the negative energy states for electrons are occupied. A hole, if there were one, would be a new kind of particle, unknown to experimental physics, having the same mass and opposite charge to an electron. We may call such a particle an anti-electron, published in Proceedings of the Royal Society, a volume 133, June 1931. Dirac has predicted antimatter, but he hedges. We should not expect to find any of them in nature on account of their rapid rate of recombination with electrons. But if they could be produced experimentally in high vacuum, they would be quite stable and amenable to observation. He thinks anti-electrons are probably impossible to detect, probably do not exist in nature, probably just a mathematical necessity. He later called this reluctance pure cowardice. California Institute of Technology, Pasadena, 1932. Carl Anderson is 27 years old, working under Robert Millikan, studying cosmic rays with a cloud chamber. The device is elegant, a cylinder filled with supersaturated water vapor, crossed by a strong magnetic field of 2.4 Tesla. When a charged particle passes through, it leaves a trail of droplets. The magnetic field curves the path. Positive charges curve one way, negative charges curve the other. The curvature tells you the momentum. The density of droplets tells you the charge. Anderson has improved the design, uses a piston for rapid pressure drop, mixes water and alcohol, gets much better photographs than anyone else. Surrounding the chamber, 800 turns of 1 centimeter copper tubing, carrying 1,600 amperes and 150 liters of cooling water per minute. A DC generator in the basement delivers 600 kilowatts. Anderson is taking thousands of photographs. Most show electrons. Some show heavy particles, probably protons, but some tracks are wrong. August 2nd, 1932. Evening. Anderson triggers the camera. Photograph number 75 in his logbook. Track 75, through lead showing energy change or double ejection. He has placed a 6 millimeter lead plate across the middle of the chamber. Particles lose energy passing through lead. The curvature increases as they slow down, so you can tell direction of travel. This track comes from below, curves left, positive charge, but the ionization density shows it is light. Electron mass, impossible. All light particles should be electrons, should curve right. Anderson has been seeing these tracks for months, mostly coming from above, which could be protons coming down, somehow losing mass. Nonsensical, but maybe. But this one is coming up through the lead plate, 63 mega electron volts energy entering the lead, loses 40 mega electron volts in the plate, exits with 23 mega electron volts. Definitely moving upward, definitely positive charge, definitely electron mass. Anderson does not know about Dirac's prediction, has not read the theoretical papers, but he knows he has something new. September 9th, 1932. Anderson publishes in Science magazine the apparent existence of easily deflectable positives. He calls them positrons, positive electrons, describes the cloud chamber setup, the magnetic field strength, the energy measurements, the ionization tracks. He's careful, calls it apparent existence, not claiming certainty, but the evidence is solid. 1 year of observations, multiple photographs. The particle has positive charge, electron mass. No other explanation fits. Patrick Blackett and Giuseppe Occhialini at Cambridge confirm it. They had seen similar tracks months earlier, but dismissed them as experimental error. Now they publish in Proceedings of the Royal Society A, 1934. Some photographs of the tracks of penetrating radiation. More positron tracks. The anti-electron is real. Dirac was right. Matter has antimatter partners. For every electron, a positron. The equation predicted this. Mathematics forced it. reality confirmed it. 1933, Nobel Prize in Physics. Dirac shares with Schrödinger for the discovery of new productive forms of atomic theory. Dirac is 31 years old, youngest physics Nobel laureate to that date. In his Nobel lecture, he explains the whole theory, describes the Dirac sea, mentions the possibility of a complete antimatter universe. Or, if we accept the view of complete symmetry between positive and negative electric charge, we must regard it as just as probable that an anti-electron would exist for as long a time as an electron you were, or that a proton would exist for as long as an antiproton. He speculates about antimatter stars, antimatter galaxies. Physical laws should be symmetric. Why do we see only matter? 1933 has no answer. But now, think about what happened here. Dirac did not set out to discover antimatter. He was trying to make quantum mechanics work with relativity. The antimatter fell out as a consequence, an unwanted consequence. Dirac resisted it for 3 years, tried to force the mathematics to say something else, failed. The equations were smarter than he was. The universe wrote its own rules in the language of mathematics, and Dirac had to learn to read what was already there. This is how reality works at the deepest level. Not designed by human intuition, not comfortable, not simple, but written in a mathematical structure that cannot be argued with. The mental process here is terrifying and beautiful. Dirac saw that relativity plus quantum mechanics demanded a linear equation in time. That forced him to find a way to take a square root that should not exist. That forced him to 4 by 4 matrices. That gave him 4 component wave functions. That predicted spin without asking for it. That gave negative energy solutions he could not ignore. That forced him to the whole theory. That predicted particles he did not believe in. That turned out to be real. 8 steps. Each step forced by mathematics. Each step taking him further from common sense. Each step correct. Here's the deeper pattern. In 1928, Dirac needed the equation to be first order in time. Why? Because the Schrödinger equation is first order in time. Probability is conserved. If you have second order time derivatives like Klein-Gordon, probability is not conserved. You get negative probabilities. Nonsense. So Dirac knew, first order in time, but relativity connects time and space. If first order in time must be first order in space, that means first order in momentum. Energy is first order in momentum, but Einstein's relativistic energy has a square root. Energy is the square root of momentum squared plus mass squared times speed of light squared. You cannot take a square root of a sum of squares with operators, but you can factor it if you use matrices. 2 by 2 does not work. 4 by 4 does, and 4 by 4 matrices give 4 component wave functions. 2 components for spin up and spin down, but what are the other 2? Dirac could not escape the answer. The other 2 are the antiparticle. The equation has no freedom. Every step is locked by consistency. Now extend this. Dirac published the equation in January 1928. Positron discovered August 1932, 4 years and 7 months. But the prediction was really May 1931 when Dirac finally admitted the anti-electron. 3 years and 4 months between prediction and discovery. In those 3 years, what was the status of antimatter? It was mathematically required but physically unknown. The equations said it must exist. Experiments had not found it yet. Dirac himself doubted it, but Anderson's cloud chamber was already taking photographs. The positrons were already there, curving through the vapor, leaving tracks, waiting to be recognized. Reality does not care if you believe in it. The anti-electrons existed whether Dirac accepted them or not. The mathematics was describing something real that nobody had seen. This is the power and the terror of theoretical physics at this level. Carl Anderson called the discovery wholly accidental. Did not know about Dirac's theory, was not looking for antimatter, was photographing cosmic rays, measuring energies, and found a particle that should not exist. But here's the key. If Anderson had known the Dirac theory, if he had been looking for the positron, he could have found it much faster. The tracks were there. Chung Yao Chao, a Caltech graduate student, had inconclusive data 3 years earlier in 1929, hinting at positrons but did not follow up. Frederick and Irene Joliot-Curie had positron tracks on photographic plates months before Anderson, but assumed they were protons. Anderson himself admitted, a wise physicist working in a well-equipped laboratory, taking the Dirac theory at face value, could have discovered the positron in a single afternoon. The anti-electrons were not hiding. They were arriving constantly from space, cosmic ray collisions producing electron-positron pairs continuously. We just did not know to look. This is what makes the story devastating. The universe was showing us antimatter for years. We were not listening. If you value documented physics history and mathematical reasoning like this, subscribe. It is the best way to support our work. Also, comment from which city you are hearing this from. Now back to the information. 1936. Anderson wins the Nobel Prize at age 31. Shares with Victor Hess for cosmic ray discovery. Youngest physics laureate ever at that time. The positron is now established, but the implications are still unfolding. If electrons have antiparticles, what about protons? Dirac predicts antiprotons in his 1931 paper, but protons are almost 2,000 times heavier, need much more energy to create them. Cosmic rays do not have enough energy at sea level. Anderson keeps looking. 1936. Anderson and Seth Nettermeyer find another unexpected particle, intermediate mass between electron and proton, 200 times heavier than electron, the muon. Nature is more complex than anyone thought. The simple picture of electrons, protons, neutrons is breaking apart. But let's return to the moment. Late 1927. Dirac staring at equations, trying to force a square root to factor, knowing this is impossible, trying anyway. Why? Because physics is broken at the boundary between quantum mechanics and relativity. Because the hydrogen atom fine structure is wrong in existing theory. Because electron spin has no explanation. Because he has faith in mathematical consistency. If two correct theories cannot be combined consistently, one of them is wrong. Or you are combining them wrong. Dirac believed the mathematics had an answer. Believed it before he found it. This is not scientific method as taught in schools. This is aesthetics, intuition, faith in mathematical beauty. Dirac later said he used beauty as his guide. If an equation is ugly, it is probably wrong. If it is beautiful, it might be right. The Dirac equation is beautiful. Simple, symmetric, first order in space and time. Relativistically covariant. The matrices are elegant. The spin-Orr structure is necessary. The negative energy solutions are unavoidable. Beauty led Dirac to antimatter, but he did not trust his own aesthetics. When the equation predicted positive electrons, he flinched, tried to make them protons. This is human. This is what makes the story important. Dirac was not a perfect reasoning machine. He was a person struggling with mathematics that went beyond his physical intuition. He made mistakes, resisted conclusions, needed other physicists to prove him wrong about protons before he accepted anti-electrons. This is how science actually works. Not clean, not linear, not obvious even to the discoverer. The truth comes through argument, calculation, objection, revision, community pressure. Weyl and Oppenheimer and Tamm and Heisenberg all pushing back, showing the proton identification cannot work. Dirac finally accepting in May 1931 what his own equation had been telling him since January 1928. 3 years and 4 months of resistance. And then Anderson finds them, without knowing the theory, without looking for them, just photographing cosmic rays and seeing impossible tracks. This is the validation, prediction before discovery. The highest form of scientific success. Theory says X must exist. Experiment finds X. Theory is right, but notice the asymmetry. Dirac needed 3 years to accept the prediction. Anderson found the particle in 1 evening of photographs. Reality is easier to discover than to accept. Now, what is antimatter actually? Not just mathematical holes. Positron emission tomography, PET scans use positron annihilation for medical imaging. Radioactive tracer emits positrons. Positrons travel a few millimeters through tissue, hit electrons, annihilate. 2 gamma rays shoot out in opposite directions. Detectors triangulate the annihilation point, build a 3-dimensional map of metabolic activity. Cancer cells metabolize faster, show up brighter. Millions of PET scans every year, based on Dirac's equation from 1928, based on antimatter that he did not believe in until 1931. Mathematics predicts. Reality confirms, technology follows, but deeper than applications, antimatter tells us the vacuum is not empty. Quantum field theory, developed in the 1930s after Dirac's equation, reinterprets the negative energy states. Not a sea of filled states, but a quantum field where particles and antiparticles are excitations. The vacuum is the ground state, but you can create particle-antiparticle pairs from vacuum if you add enough energy. 2 photons collide with sufficient energy, become an electron and a positron. Mass from energy. Einstein's equation reversed. Antimatter is evidence that mass and energy are interchangeable, that particles are not eternal. That creation and annihilation happen constantly at small scales. The vacuum seethes with virtual particle-antiparticle pairs appearing and disappearing. This is Hawking radiation at black hole horizons. This is the Casimir effect between metal plates. This is quantum electrodynamics, giving the electron magnetic moment to 1 part in 10 to the 9th. Antimatter is not exotic. It is fundamental to how reality works at quantum scales. The Large Hadron Collider at CERN produces antimatter constantly. Proton-proton collisions at 14 trillion electron volts. Hundreds of particles and antiparticles spray out from each collision. Antiprotons, antimuons, antineutrinos. Most annihilate immediately, but some are captured. CERN's antiproton decelerator slows antiprotons to low energy, combines them with positrons, creates antihydrogen atoms, traps them in magnetic bottles, studies their spectrum. Testing if antimatter obeys the same physical laws as matter. So far, yes, perfect symmetry. But if perfect symmetry, why is the universe made of matter? Why not half matter, half antimatter? This is baryogenesis. The matter-antimatter asymmetry. Something in the first microsecond after the Big Bang favored matter over antimatter by 1 part in 10 billion. If not for that tiny asymmetry, all matter and antimatter would have annihilated. The universe would be pure light. No stars, no planets, no atoms, no us. That asymmetry is not explained. Dirac's equation predicts perfect symmetry. Reality has an asymmetry. We do not know why. This is one of the deepest unsolved problems in physics. But return to the moment of discovery. 1928, Dirac derives the equation, sees the negative energy solutions, has 3 choices. First, the equation is wrong. Throw it away. Start over. But the equation works too well. Predicts spin exactly. Fine structure perfect. Cannot be wrong. Second, ignore the negative energy solutions. Call them unphysical. But quantum mechanics does not allow ignoring solutions. If the mathematics gives an answer, the answer means something. Third, accept the negative energy solutions. Find a physical interpretation. This is what Dirac chose. But it took him 2 more years to find the interpretation, hole theory, and another year to accept that holes are not protons. Mathematics gave him the answer in 1928. He accepted the answer in 1931. 3 years of struggle. This is the mental process. Not instant revelation, not obvious even to the discoverer. Slow, painful acceptance that the mathematics knows more than you do. And here is what changes when you see this. Reality, at the smallest scales, is not built from human intuition. It is built from mathematical structure, and that structure has properties we do not choose. Relativity plus quantum mechanics forced Dirac to 4 by 4 matrices. 4 by 4 matrices forced 4 component wave functions. 4 components forced antiparticles. At every step, consistency demands the next step. You cannot pick and choose. The mathematics is a package deal. Dirac wanted a relativistic electron equation. The mathematics gave him antimatter. He did not order antimatter. It came with the electron. This is why physics is so strange at quantum scales. Not because nature is weird, because mathematical consistency is stricter than human intuition. So the equations have to work together. And when they do, they predict things that sound impossible but turn out to be real. Now look at what this means for how we understand the universe. Before Dirac, matter is electrons and protons. Simple, stable. After Dirac, every particle has an antiparticle. The vacuum is a quantum field. Particles are excitations. Creation and annihilation are possible. Mass is energy. The universe is dynamic at the smallest scales. One equation changed our entire picture of reality. Because the equation was consistent with relativity and quantum mechanics, consistency forced the change. Dirac did not impose his view on the universe. He followed the mathematics. And the mathematics led to antimatter. This is the mental process that changes how you see reality. Not, I have an idea, let me test it, but I have these 2 theories that must both be true. Let me force them to work together. Let me see what consistency demands. And then, the consistency demands something I did not expect. Do I trust the mathematics more than my intuition? Dirac trusted the mathematics. Took him 3 years, but he trusted it. And the mathematics was describing something real. The positron was real before Anderson photographed it. The antiparticle was real before Dirac accepted it. The mathematics was seeing further than human intuition. This is the lesson. Mathematics is not just a tool, it is a way of seeing, and sometimes it sees things that are true before we are ready to believe them. Carl Anderson died January 11, 1991, lived to age 85. Spent his entire career at Caltech. The cloud chamber he used is still there, donated to the California Institute of Technology archives. Diameter 16 centimeters, width 4 centimeters. A simple device, water vapor, magnetic field, camera. But it revealed a new kind of matter. Because Anderson had the patience to take thousands of photographs and the honesty to admit when the data showed something impossible. Paul Dirac retired from Cambridge in 1969, moved to Florida State University, closer to his elder daughter, continued working on physics until shortly before his death. October 20th, 1984, Tallahassee, Florida, age 82, buried at Roselawn Cemetery. November 13th, 1995, a memorial was unveiled in Westminster Abbey, green slate from Burlington, inscribed with the Dirac equation, next to Newton's grave, the equation that predicted antimatter. The equation that changed reality. But the final piece, that green slate at Westminster Abbey, the dean, Edward Carpenter, initially refused permission for the memorial, thought Dirac was anti-Christian, took 5 years to persuade him, finally relented. The equation is there now, for anyone who wants to see. And if you look at it, really look, you see something impossible. 4x4 matrices, first order in space and time, relativistically covariant, and buried in the mathematics. The prediction that for every particle, there is an antiparticle. This was not philosophy, not speculation, not a guess. It was mathematical necessity. Dirac followed the mathematics. The mathematics led to a new form of matter. That form of matter turned out to be real. This is not how we usually think science works, but this is how it actually worked at the moment antimatter was discovered. In 1995, physicists at CERN created the first antihydrogen atoms, antiproton plus positron, the antiparticle version of the simplest atom. It lasted for 40 nanoseconds before annihilating, but it existed. In 2010, CERN trapped 38 antihydrogen atoms for 1/6 of a second. In 2011, trapped atoms for over 15 minutes, long enough to study. The spectrum matches hydrogen exactly. With an experimental error, perfect symmetry. Dirac would have appreciated that. The mathematics predicted symmetry. Nature confirmed symmetry. 63 years after Dirac predicted antihydrogen in his 1933 Nobel lecture, and in 2017, the Alpha collaboration at CERN measured the spectrum of antihydrogen to 9 decimal places. Matches hydrogen to 9 decimal places. The antiparticle obeys exactly the same quantum mechanics as the particle. This is the validation continuing. Not just that antimatter exists, but that it behaves exactly as the mathematics predicted. The Dirac equation says particles and antiparticles are related by charge conjugation symmetry. Should have identical properties except for charge. They do. 8 decades of experiments. Every test confirms the mathematics. The equation was right from the beginning. So what was the mental process? Start with a problem. Relativity breaks quantum mechanics. Force them to work together. Use mathematics as the forcing function. Let consistency decide the answer. Accept what consistency gives you, even if it sounds impossible. Wait for experiment to confirm or deny. If confirmed, the mathematics was seeing reality. If denied, start over. In Dirac's case, confirmed. The mathematics saw antimatter before experiment did. This is the method, not unique to Dirac, used by every physicist working at fundamental levels. Trust the mathematics, follow the consistency. Accept the implications, test the predictions, revise if wrong. This is how we learned that space is curved, that time is relative, that particles are waves, that the vacuum is not empty, that antimatter exists, not by guessing, by following mathematical consistency until it leads somewhere strange, then checking if that strange place is real. But here's the final twist. In 1932, soil samples from the Guggenheim Aeronautical Laboratory where Anderson worked show residual radioactive traces, cosmic ray bombardment over decades. The positrons were hitting the building continuously, thousands per day. Every cloud chamber photograph was selection from a constant rain. The antimatter was not rare. It was everywhere, arriving from space, produced by cosmic rays, annihilating in air, in water, in the chamber walls. We swim in a sea of antimatter and normal matter constantly colliding, constantly creating and destroying each other. The asymmetry is large scale. Matter dominates. But at small scales, locally, temporarily, antimatter is common. And it all followed from one equation, one attempt to make relativity and quantum mechanics work together, one physicist following mathematical consistency wherever it led, Paul Dirac staring into a fireplace in late 1927, wondering how to take the square root of an equation that should not have a square root, and finding that the universe wrote its own answer.